Nothing in the night sky is quite as magical as shooting stars among all other phenomena. Yes, comets are more spectacular, but they only appear every 10 to 15 years or so. On a clear night, you'll undoubtedly see at least one shooting star if you have a little patience. Strictly speaking, meteors are a better name for shooting stars. The majority of them were once part of the asteroid belt, but they were knocked out of their orbit by a passing planet and ended up landing on Earth. Around 48 tons of meteors, according to NASA, reach our atmosphere every day. Of the 25 million or so that fall under our gravitational pull, only about 17 make it to the surface and leave behind a prized find for meteor collectors. But not every meteorite, one that has collided with Earth, is created equal. As previously stated, the most of them originate from the asteroid belt between Mars and Jupiter. Yet, some of them originate from the comet debris tracks that passed through the Oort cloud or Kuiper belt, and the Earth has at least once caught a meteor from outside the solar system. In general, shooting stars go through 3 stages of their lives. They are known as meteoroids when they are traveling through space. Meteors are what they are known as they streak over the night sky. And if they make it through our sweltering atmosphere alive, they are known as meteorites. The observation of meteors striking the ground is unusual. They are typically discovered many years after the occurrence. How do we know they originate from space, then? They are aged. On Earth, rocks are recycled constantly, though very slowly. And at the high end, they are a few billion years old. The oldest rocks on Earth are 4.25 billion years old, whereas the oldest rocks from space are 4.5 billion years old. This is because these rocks formed along with the solar system and haven't gone through any significant changes since then. Meteoroids are moving fairly quickly since they follow Earth's orbit around the Sun. Around 18 miles per second are being traveled by the Earth as it orbits the Sun. Meteoroids must be moving at least that fast to avoid colliding with the Sun. Yet because meteoroids can strike us from any direction, their speed relative to the Earth when they ignite in our atmosphere can range from 7 to 44 miles per second. Oumuamua, the first interstellar object discovered, entered our solar system in 2017. Its intergalactic origin was identified based on the direction it came from and the relative speed it was traveling in relation to the Sun. 2 years later, Harvard professor Avi Loeb and then undergraduate Amir Siraj searched the Center for Near-Earth Object Research database for any unusual meteors in an effort to find further probable extraterrestrial visitors. Siraj identified a potential match in a 2014 item that crashed to Earth off the coast of Papua New Guinea within a few days. The 2014 meteor, formerly designated CNEOS January 8, 2014, was moving roughly 28 miles per second relative to Earth based only on the data contained in the CNEOS database. Siraj teased out the numbers and discovered that the meteor entered the atmosphere on the backside of the planet as it spun around the Sun, giving it a speed of 37 miles per second relative to the Sun, faster than anything in the solar system. This speed alone was already enough to hint that this could be an interstellar visitor. The first known detection of an object from outside the solar system would be made by Amir Siraj and Avi Loeb, if what they discovered was an interstellar meteor. The report verifying their findings was the only thing left to do. There was only one issue. They used data from the CNEOS database, which was obtained through a collaboration between NASA and the Department of Defense. Siraj and Loeb would need to be aware of the margins of error associated with their data in order to support their astounding assertions. But such information was secret, since it belonged to the Department of Defense and could be utilized by U.S. adversaries. Their article spent 3 years in preprint purgatory without such information. The two had roughly estimated the margins by comparing other meteors in the CNEOS database with publicly available data. But the rigorous nature of research demands more than simply conjecture. It wasn't until a memo from the U.S. Space Force in 2022 that they were validated, confirming their conclusion that CNEOS January 8, 2014 was an interstellar object, despite receiving confirmation of their numbers from an unnamed source. While the fact that this meteor came from outside of our solar system is intriguing enough, other CNEOS January 8, 2014 peculiarities have inspired Avi Loeb, Amir Siraj's professor, to postulate some astounding possibilities. The meteoroid was moving at a speed of 37 miles per second, 133,200 miles per hour, with respect to the Sun, as was already indicated. It would have to have come from either the center of an alien solar system or have traveled from a distant region of the galaxy for an item to reach those kinds of speeds relative to our system. Besides, it was quite difficult. The strongest meteors that the Earth has snagged are primarily comprised of iron. Siraj and Loeb calculate that Cineos January 8, 2014 must have been nearly twice as powerful based on the flares it produced and the estimated altitudes at where they occurred. In fact, it outperforms every other object they could compare it to in the CNEOS database in terms of strength. These astounding findings suggest that the meteor may have evolved near a supernova or neutron star merger, where it may have gained its heavier-than-average composition and extraordinary speed. Thus, in Loeb's opinion, it might have an artificial beginning. Whether Cineos January 8, 2014 is man-made or natural in origin, the possibility that there are still interplanetary debris fragments on Earth is remarkable. Avi Loeb is seeking to organize a $1.5 million expedition to uncover pebble-sized pieces of debris from outside the solar system at the bottom of the Bismarck Sea off the coast of Papua New Guinea, because the idea of doing so excites him so much. The strategy is both straightforward and bold. Loeb intends to hire a boat and examine a 40-square-mile area of the ocean floor using an underwater sled fitted with a magnet for any possible meteorite debris. Although there are many critics of Loeb's theory in the scientific world, he has so far raised $500,000 despite their doubts. Only 2 additional interstellar objects, Cineos, January 8, 2014, and Oumuamua, have been discovered by scientists. A comet traveling through the solar system at 110,000 miles per hour was discovered in 2019 by a lay observer. Amir Siraj and Loeb also discovered another probable interstellar meteor in the Cineos database in September.